Hello YouTube, RJ. Just a short little video. One of the things that I wanted to add was for my Siglent SDG 1032X arbitrary waveform generator that also works as a frequency counter. I wanted to get a little more accuracy. The clock that comes in at standard is 25 parts per million within a year. I was looking for something a little better, so like a lot of people, I broke down and bought myself a 10 megahertz clock, external clock for it. So I just wanted to give a quick brief of that. I had one of these little snap together plastic boxes left over from another project that'll come out on another video, and so I decided to use it. It actually worked out quite well. Let me pop it open here for you. It worked out quite well for this. Made it very easy. Basically what I did is it doesn't have places to mount circuit boards, so what I did was I just made some holes for the SMA, made a hole for the DC power jack to come through, and found that since I had to put an adapter to bring it to a BNC connector for me, I found that if I just put one metric washer here under it, it tightened up perfectly. It worked out absolutely perfect. This SMA is making full contact, but yet it's tightening the board in, so it's stable. It's great. Now these things are, you pick them up on AliExpress or eBay or whatever. They're, the little module, if you just want to get it separate, you can pick those up for like $5, even less. I bought the whole complete board ready to go, and which is nice, and I think I paid like 14-15 bucks for it. So it's not a lot of money. So I thought I would show you what it looks like on the oscilloscope and spectrum analyzer, see how clean it is. And so let me hook it up here. One thing to keep in mind, my spectrum analyzer has 50 ohm termination. So we've got a 50 ohm termination for this that works well. If you don't have that, make sure if you're just putting on a scope, since it's not going to be 50 ohm, that you use a 50 ohm termination like this onto your scope. Otherwise you're going to get some ugly waveforms. It's not going to look too hot, because oh, that's nice, dropped it, but they expect 50 ohm termination. So with that in mind, this looks really good. Nice sine wave, no harmonics. Now there's two outputs. There's a TTL square wave and a sine wave. I'm using the sine wave because I don't want all the harmonics floating around in the lab. And these things put out a pretty good signal. So you could bad cable or something, you could get some RF floating around out of this thing. So I'm using a sine wave to keep down on that. And you can see here on the spectrum analyzer, it's really clean. It's got a nice peak, dead on 10 megahertz. No harmonics really showing up out of the noise, no spurs. Very, very, very clean. So with that in mind, that's it. Now what I'm going to do is I'm going to put this behind the signal generator, and I've got a small little coax that I'll hook to it, to the external input for 10 megahertz reference clock, and I'll show how to set it up and make sure that you're on the external clock. So let me pop this back together, and I'll reposition some cameras, and I'll be right back. Okay, and so I've repositioned the cameras. I didn't want to make everybody seasick, so basically on the Siglent, to change from your internal to the external, you go into your utility. You have to go to page 2 into the clock, and it's real simple. Source internal, hit internal, external, you're done. Hit return. If you've got your unit set up to return all the settings back to the last settings, it'll stay that way. So you won't have to do that over and over again. So that's it. Now I'm set up with, with it using my external very, very stable oscillator, which was calibrated before it was shipped to me to 10 megahertz. So it should stay pretty close to dead on 10 megahertz for quite a while. At some point I'll have to look at getting a discipline clock, GPS discipline clock or something for calibrating, but we're not so much worried with what we're going to be doing with exact frequency as much as how much has it changed. And this oscillator will make sure that any changes is really what we're testing and not the counter itself, clock drifting. So that's it. Real simple, real straightforward, and just thought we'd show you how we're setting up to do some of these tests that are coming up. So catch you in the next video. Thanks a lot for watching. If you like the content, please subscribe. See you later.